I guess what we're going to be talking about here is a different type of series. So far, we've talked about a couple different types of series. We've talked about a geometric series and how we can tell whether or not that is convergent and what it's convergent on. Then we talked about a p-series, and we said whether or not we can tell whether that's convergent or divergent. Now we're going to expand. It's going to be more of the p-series that we're going to expand just a little bit. We are going to expand and find out what is known as an alternating series. So when we look at an alternating series, again, remember a series is just we're adding a whole bunch of numbers together, and from one term to the next, they follow some sort of pattern. So an alternating series, and it's simply put, when you look at it, the first term is either positive or negative, and then the next term after that, even though we won't know specifically what the term is, they switch signs. So it's like it goes positive, then negative, then positive, then negative. It's possible that it goes negative, then positive. We just see that the sign of one term to the next is alternating. Now, when we look at an alternating series, you can usually identify an alternating series really quickly because, and it's not always the case, but it's usually like this. There's a term in the series that has -1 raised to the nth power. When we see a raise like that, if you think about it, regardless of what the series is, like if I was starting at 1 here with this infinite series, when I plug 1 in, -1 to the first power gives me a negative number. Then I plug 2 in, -1 to the second power gives me a positive power. And it would cause my terms, although I don't know what they are in this particular series, it would cause my terms to go from negative numbers to positive numbers, negative to positive, negative to positive. If we see that, then we have an alternating series. And again, this right here, this a to the nth power, that's just some series being raised to a number power. It might be a p-series. It might be a geometric series. There are other types of series that we have not talked about. There are a lot of series that we won't talk about in this class. But be aware that that is the key when we're looking at an alternating series. Now, if you remember, when we talked at the very end about a p-series, there was a special type of p-series called the harmonic series, where it looked like, when I looked at it initially, it looked like it was convergent, but in reality it was divergent. In this problem here, what this is basically saying is I'd have 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5. Again, because what I really have here is -1 to the n plus 1 power, and then I'm just multiplying that by our harmonic series like we talked about before. And numbers, when we look at numbers, like just plain old numbers that exist outside of a series, technically we can take those numbers and just ignore them while we plug everything else into the series and then multiply by it at the end if the number is the same. Anyway, with this series that we have, oops, that'd be a minus there instead of a plus. With this particular series we have, initially you might think, okay, well, because the harmonic series, I thought it was convergent, but it's really divergent. Maybe when I look at the alternating version of that series, it's also going to be divergent. So before we look at whether or not it's going to be convergent or divergent, there's actually two criteria when you're looking at an alternating series. And to be honest, both of them have to do with the term that does not involve the alternating part. So basically, when we look at an alternating series, to tell whether or not it's convergent or divergent, we just say, okay, I'm going to ignore the part that's making it go back positive, negative, positive, negative, positive, negative. I'm going to completely ignore that fact. Instead, what I'm going to do is I am just going to look at the other part of it and see if these two criteria are met. Now, the first criteria is that as we look at the terms that get really, really large, it has to go to 0. In other words, if I have my series, and let's say I had 1 over, I'm just making this up, 2 to the nth power, or something like that. I would take infinity and I'd plug it in, and as long as I get 1 over a really big number, so basically 0, I can say, first of all, okay, that meets my first criteria. Now, the second criteria, and this one is a little bit different, and we actually talk about that. This one, again, right here just means my terms are getting smaller and smaller. Okay, that's the first thing. The non-alternating part, the terms are getting smaller and smaller. The second part means, okay, as my terms get smaller and smaller, there's nothing that's going to throw me off. It's not going to be like alternating back and forth. Like every term has to be getting smaller from one term to the next. And the way that we show that technically is we list the first 5 or 6 terms to show that's happening, and then we show like the general term. Now, quite honestly, a better way to do that is just look at it. Okay, just look at it and say, okay, this is all I have to do. I'm not going to worry about the showing part because on the AP test, that's never something that you're required to do. You're never required to show that all the terms are getting smaller. And that's really all this is saying. I can't be hopping back and forth, up and down. One thing that would cause it to not do that is if I had sine of x divided by like x squared. Although we talked about a problem like that, or at least we should have talked about a problem like that, where the sine of x is always between -1 and +1, because that's going up and down, not every term is going to be consecutively smaller than the term that came before it, okay? And so that is, again, both of those things have to be true. Now, really, you don't have to worry about it as long as, honestly, there's like a horizontal asymptote of 0. In other words, the power on bottom is bigger than the power on top. On our non-alternating part of each term, then you're good to go. That's what all of that is saying. Now, if you think about it, if we're looking, let's look at that harmonic series again, and the alternating harmonic series. So I had -1 to the nth power multiplied by 1 over n. Now, you think about this for a second, you're like, okay, if my first, and I think I had n plus 1 is what I had. My first term was +1. So if I start at 0, I'm just going to be adding a bunch of numbers together. So I'm going to go over here to 1. Then I'm going to go, okay, plus, the next thing I'm going to do is I'm going to, -1/2 is going to be the next term. In other words, I'm subtracting 1/2 from that. So I would only go back halfway. Then the next term I'd get plus 1/3. So I would go back in this direction, but I wouldn't go quite as far, because I'd only go 1/3 in that direction. Minus 1/4. And I think you can kind of see the idea here. The one thing that is true is I cannot tell what number the series is going to be convergent on. But I can tell, because you'll notice I'm just adding each of these up, and it looks like what's happening is I'm getting closer and closer to some number that's within that little region right there. So that's what's happening with us using this number line here. I'm saying, okay, I can see that it's going to be convergent. And again, hopefully that kind of makes sense. So let's look at this problem and basically say, okay, is this alternating harmonic series convergent? We already talked about it. Because I take the limit as n approaches infinity of 1 divided by n, I get 0. That meets the first criteria. Then the second criteria is I look at all of the terms, 1 plus 1/2 plus 1/3 plus 1/4. Each term is smaller than the term that comes before it. And we'll talk about a test that we can use for that in a future video. But that's how you tell whether an alternating harmonic series is convergent. Here's another one. Notice this part right here is making it so that it's an alternating series. Negative number, positive number, negative number, positive number. What I want to look at now is everything else, and I'm going to more or less look at the limit as n approaches infinity. So I'm going to do the limit as n approaches infinity here of this particular series. Because I want to know what happens as I get way, way out there. Okay, so I get n plus 3 over n squared plus n. When I do that, I plug infinity in, top and bottom, and I can see the power on bottom is bigger than the power on top. That means this is 0. So this meets the criteria, okay? And again, the other criteria where it meets where each of the terms must be consecutively smaller, there's actually ways that you can get around that. So really, this is the only thing you need to check to see whether or not an alternating series is going to be convergent when we look at it like this. So here's another one, okay? So I've got -1. There's that -1 to the n. I'm going to ignore that part. Then I've got n over n plus 2. Now, when I do the limit as n approaches infinity of this one, remember, if the power is the same on the top and the bottom, that is not a convergent series because the limit is equal to 1. That means every single time when my terms get way, way out there, I'm going to get 1 plus 1 plus 1 plus 1 plus 1. I mean, basically 1, which is what it would be, but it would be alternating. So it'd go 1 plus -1 plus +1 plus -1. We talked about this a little bit before when we were talking about convergence of series. Although that would not be infinity, it would not be a specific number. It would keep bouncing up and down between a particular number. It would never get close to a number as my terms got bigger and bigger and bigger. So this one right here would be divergent. Now again, one thing I want to emphasize is that you can't tell what these series are going to be adding up to. you can only tell whether or not they're convergent or divergent, and that actually holds true for all, like we're never going to find a way to figure out exactly what this adds up to. The only series we can ever tell what it's going to add up to is a geometric series. That's the only one. There's other ones where we could maybe estimate it, but that is the only one that we are aware of that we can find out exactly what it adds up to. So hopefully that makes sense about what an alternating series is. We'll talk about a few other things when it comes to alternating series, but hopefully that made sense. If you have any questions, please let me know.